Alright, good morning, everyone. Good morning. Alright, so I'm going to review some stuff. We're getting ready for that final, which should be on Friday for y'all, I believe. It's, odd-numbered classes are going to be on Thursday. Even-numbered classes are going to be on Friday. So, just looking at, acids and bases some more. So, part of the final is going to be a short section of vocabulary and also some things that are different about acids and bases. And so first off, acids always have a pH of less than 7. Remember to look at pH, don't look at pOH. pOH is the opposite. pOH will be greater than 7. But when we're looking at whether something's an acid or base, we want to look at the pH. And so bases are the opposite. Bases are a pH of greater than 7. It would be a pOH of less than 7. So some more stuff about acids. So they're going to taste sour. So if you think about like a lemon head, or a warhead, some kind of candy. Lemons, oranges. I draw an orange. They're all kind of sour. Whereas something that's a base is going to taste bitter. Don't try it, but, if you grab a bar of soap, that's not going to taste very good. It's going to taste a little bitter. Yeah, don't try that at home. It's not tasty. A couple other things. So, fundamentally what an acid is it's a proton donor. So basically that means, if you remember going all the way back to the periodic table, if we remember our protons, neutrons, and electrons, well, if we've got one proton all by itself, and that's just a hydrogen atom, an H+. It's a hydrogen atom that has lost its electrons. So acids are all about trying to get rid of those hydrogen ions. They're donors. They give them up. They also have an excess of hydrogen ions. So they have a lot of these hydrogen ions. That's why they're donors. They're giving them up. And they're also going to turn blue litmus paper red. So acids, they have a pH of less than 7. They tend to be sour. They're proton donors. They give up protons. They have an excess of hydrogen ions, H+, which is what we look at when we calculate pH. And they turn blue litmus paper red. Whereas bases are proton acceptors, so that hydrogen ion is going to go to the base. It's going to be accepted by the base. And instead of having extra hydrogen ions, bases have hydroxide ions. There's an XIDE because it's got oxygen. It's an OH minus. And then because they're the opposite of acids, they're going to turn red litmus paper blue. Blue for base. B. Blue. Blue for base. And then if you look at, when you combine the two, when you add them together, what you get is that hydrogen ion plus that hydroxide ion. Well, those two are going to combine, and they're going to give you H2O. They'll give you water. They'll also give you a salt. So the salt could be things like sodium chloride, but it could also be potassium chloride, sodium fluoride. It could be a bunch of different things. But what we call something that's made from an acid and base reaction is a salt. And we call this kind of reaction a neutralization reaction. So if you have something with a pH of like 6, and you mix it with something that's got a pH of like 8, you'll probably get something with a pH of like 7. Depends on how much of what you're mixing together, whether it's diluted or not. But that's what we call a neutralization reaction. So a neutralization reaction is going to move the pH a bit to the middle. It's going to create water, and it's going to create a salt. Okay. So let's look at some ways we can calculate the pH given a concentration of hydrogen ions. Do some practice problems. So if we have H plus, we take negative log of H plus to get pH. So if we have H plus, we take negative log of H plus to get pH. So negative log, you just need to be able to find that on a calculator. We'll look at calculators for early tomorrow, ready for the test. We'll be using these guys right here. The log button is going to be this button right here. So you'll hit negative log, and then you'll type in whatever number. So something to remember when doing these problems is that pH can be negative. It can be bigger than 14, but it probably is not. Not for the kinds of problems we're going to work. That would be very, very strong. So if you get confused on this negative part, well, your pH should probably be positive. So if you get a negative number, you might just double check your math. So let's say we've got 0.024 molar of hydrochloric acid. So we've got hydrochloric acid, and it's got a concentration of 0.024 molar. So there's one H, so that H is going to have the same concentration. H plus is going to be the same. It's going to be 0.024. And so for my pH, I just plug in negative log of 0.024. I'm going to go ahead and type that in my calculator. So I've got negative log. When you type in negatives, you're going to want to use this button right here. You don't want to use the minus button. For some reason, calculators don't like the minus button for negative, so you want to use the negative button that's up here. So it'll be negative log of 0.024. And so it'll look something like this. And so I have a pH of 1.6. And so then I have my pH, and because my pH is less than 7, it's 1.6, it's an acid, and I want to remember that when I'm looking at acid or base, I want to look at pH, not POH. POH will give me the opposite, so I want to make sure I look at pH when I'm determining whether something is an acid or a base. And so if we have pH, we can find POH by taking 14 minus pH. So taking that last problem I did, if I want the POH, I take 14 minus 1.6, and I get 12.4. That's my POH. And then the last thing I can find with these two if we have POH, we take 10 to the negative 12.4, 10 to the negative POH, and that will find hydroxide, OH. So just like before, I type in my calculator, I say 10 to the negative, let's see, negative 12.4. And I get 4 times 10 to the negative 13. So one way to think about these problems, if I get a number that is bigger than 1, I want to double check my math. My number should always be less than 1. 10 to the negative 13th is very, very small, much less than 1. So my number should be pretty small. My number should be, in scientific notation, they should be 10 to the negative something. If I get 10 to the positive something, then there's probably something wrong with the math I did. So just by using H+, we were able to find all these other parts, these other attributes, characteristics, things. Let's start with something with OH. So if we have OH, we find POH equals negative log of OH. So for example, let's say we've got 0.075 molar of potassium hydroxide. It's got a hydroxide and OH in it, so I'm going to make sure that I know that OH is what I'm looking at here. If I want POH, I take negative log of 0.075. I type that in my calculator once again. I'm expecting a positive number. It should probably be a positive number. and I get 1.1 as my POH. And I say, if we have POH, we find pH. pH equals 14 minus POH. So that would equal 14 minus 1.1, which gives me 12.9. Because my pH here is bigger than 7, this is going to be a base. It's going to be a base. I'm looking at my pH. I don't want to look at POH. POH will confuse me. And then if I have pH, we can find H plus. H plus equals 10 to the negative pH. So that's going to be 10 to the negative 12.9. I type that in my calculator, 10 to the negative 12.9. And I get 1.3 times 10 to the negative 13, which is good. I'm expecting a small number. So that's my concentration of hydrogen ions. So the pattern is negative log will get me H plus and OH. 10 to the pH or 10 to the POH will give me H plus and OH. Okay, so let's do a review of molarity. So first step, if you've got grams, you probably want to turn them to moles. Or if you've got moles, you probably want to turn them to grams using the molar mass. So if I have, say, 10 grams of sodium chloride, I'm going to take it, and I'm going to divide by the molar mass. I'll put 1 mole on top, and then I'm going to take my periodic table. Zoom in. I've got sodium chloride. So I take 22.99. Plus chlorine. Chlorine is 35.45. And these are going to be in grams. And so then I'll just add those two together using my calculator. Let's see. There we go. I get 58.44. then I just take everything on top and divide by everything on bottom. So 10 divided by 58.44. And I get 0.17. And this is in moles. So I turn grams into moles. If instead I had moles and I wanted to turn them into grams, say I had 2 moles of sodium chloride, then I just flip it. I want my moles on bottom to cancel them out. Whatever I'm getting rid of always goes on bottom. Whatever I want goes on top. And so I get 58.44 grams. Just basically flipped what I had upside down. Multiply everything on top. Divide by everything on bottom. And I get 116.88. And that's in grams. My moles will cancel. Grams canceled up here, moles canceled down here. So that's always my first step, depending on what the problem asks me for. And then depending on the problem might give me number of moles in liters. And it might ask me for what is molarity. Well, if I have number of moles and I have number of liters and I'm asked for molarity, all I need to do is divide number of moles by number of liters, and that will give me molarity. If instead the problem gives me number of liters and molarity, and it asks me for number of moles, well, I gotta remember molarity, big M, is moles per liter. So if I multiply big M by L, I'll get just moles. So if I've got number of moles and number of liters, I divide. If I've got number of liters and number of molarity, I get number of moles. I multiply. Or if I get number of moles and big M, and I'm looking for number of liters, if I remember number of moles, I'm going to divide. I'm going to divide by big M. So big M times L, moles divided by liters, and then moles divided by big M. Depending on the problem. So let's say I've got how many grams of potassium carbonate are needed to make 200 milliliters of a 2.5 molar solution. So first off, I'm going to convert this into liters, this milliliters right here. I'm just going to divide it by 1,000 to make it into liters. I want to be working with moles and liters. So I divided it by 1,000 just to make it liters. And so I've got a problem where it's asking me for grams. I've got liters, I've got molarity. So first I'm going to need to find moles. So if I've got liters and molarity, I'm going to be multiplying M times L. So I've got 0.2 L times 2.5 M, which is moles per liter. And I get 0.5 moles. And then next up, I need to convert that to liters. So I've got 0.5 moles. I'm going to convert that 0.5 moles into grams. So to convert into grams, I'm going to make sure moles go on bottom, grams go on top. First step, I've got potassium. I got 2 of them. I find that molar mass of potassium, which is 39.098. Plus carbon, which carbon is 12.011. Yes. No worries. It's like 5 people there. Alright. So 12.011 plus 4 for my oxygen, so that's going to be 15.999. Then I add up everything together. And I get a grand total of 154.20 grams. Multiply everything on top, divide by everything on bottom. I get 77.10 grams. Right? Next up, how many liters of 4 molar solution can be made using 100 grams of lithium bromide, LIBR. So this one is giving us molarity, and it's giving us grams, but we need liters. So first step, we need to convert our grams into moles. So I've got 100 grams of lithium bromide. Want moles on top because that's what I'm looking for. I go find my lithium bromide on the periodic table. I've got 6.94. plus bromine, which is 79.904. That's in grams. I add them together in my calculator, 6.94 plus 79.904. And I get 86.84. Divide 100 by 86.84, dividing everything on top by everything on bottom. I get 1.15 moles. And then this problem, well, I've got moles and I've got molarity. So going back to my list of equations, if I'm looking for liters and I've got moles and molarity, I'm going to take that number of moles and divide by molarity. So 1.15 grams divided by 4 moles. No, not grams, sorry. That should be in moles. There we go. 1.15 divided by 4 equals 0.29 liters. Let's do one more. How many grams of copper fluoride are needed to make 6.7 liters of a 1.2 molar solution? So this is a problem that's giving us liters, and it's giving us molarity, and it's asking for grams, but to get grams we need moles first. So going back to these equations, we've got liters and we've got molarity, so we're looking at molarity times liters. So we're looking at 6.7 liters times 1.2 moles per liter. Which gives us 8.04 moles. And then 8.04 moles. We need to turn that into grams, so 8.04 moles. Going to divide by 1 mole, multiply by that molar mass. 1 copper. Has a mass of 63.546. Plus, we've got 2 fluorines. Those 2 fluorines are going to multiply 18.998. type that all in a calculator. I've got 101.54 grams multiplied by 8.04. And I've got 816.40 grams. Okie dokie.